Welcome back, guys. So in this part we're going to discuss about another concept, that is relative velocity, and a standard question in that is holding an umbrella against rain, in which many students get confused with the angles and the direction as to how to take the relative velocity and how to find the angle with respect to the vertical. So we'll understand the concept first and then we take up a numerical. So basically there's a man who is running and he's holding an umbrella, and as rain falling either vertically or at some angle. For the sake of simplicity, I've taken it as vertical, but it can be another direction as well. So what we have to do is to find the velocity of the rain with respect to the man, so that when the man knows the velocity of the rain with respect to him, he can hold the umbrella in the right direction to avoid getting wet. So the easiest way to do this is to just put up a vector diagram at one point. So take this as the point. Take VR as the velocity of the rain, Vm as the velocity of the man, and what we basically have to do is to find Vrm, which is equal to the relative velocity of rain with respect to man, which is the velocity of the rain minus the velocity of the man. Now the easiest way to do this kind of subtraction is to add Vr and minus Vm vector to get another vector, that is Vrm vector. Since we have found Vrm vector very easily by considering this parallelogram in case of some questions, so now all we have to do is just take the opposite of Vrm, which is the direction in which you should hold the umbrella, and in most cases they ask the angle with respect to the vertical. So if you draw a vertical like this, it is this angle that they are asking for. So very easily we are able to find this angle. So let's apply it in this question. So in this question they're saying that the velocity of man is 4 km per hour and the velocity of rain is 3 km per hour. They're asking to find the angle at which the man should hold umbrella with respect to vertical to avoid getting wet. Basically it's this angle. So again, if you put up a diagram over here, this would be Vm is equal to 4 km per hour, and this would be V rain is equal to 3 km per hour. So if we take minus Vm, it would be in this direction, and then if we do Vrm, we would get this vector, and this would be the direction at which you should hold the umbrella, and this is the vertical with respect to which you have to find the angle. So it's this angle theta that they're asking us. So how do we find this angle? It's pretty easy actually. You just have to take you just have to find this angle. That's because it's obviously these both are vertically opposite angles, so they're equal to one another. So now let's find out this angle. So to find out this angle, we can consider this triangle I just completed over here. This is Vrm, this is minus Vm vector this way, and this is Vr vector. This is the angle theta. So if we take tan theta, it would be magnitude of minus Vm vector divided by magnitude of Vr vector, which is equal to 4 divided by 3. So if you know some angles, you know that theta is equal to tan inverse of 4 by 3 is equal to 53 degrees. So the angle that the man should hold the umbrella with respect to vertical is 53 degrees. So if suppose this was the man and he was running at 4 km per hour and rain is falling vertically at 3 km per hour, he should have umbrella in his hand which he is holding at an angle theta, and this angle theta is equal to 53 degrees. This angle theta is 53 degrees. So this is how we easily solve this relative velocity questions. It need not just be the umbrella and the rain. There are many such type of questions which involve relative velocity, and it's very important to understand the difference between relative and resultant velocity, as some students get confused between these two terms. So resultant velocity is the resultant of two vectors. It's like the addition of two vectors, as we saw previously. We added the velocity of the swimmer and the velocity of water, but in this case, what we have to do is to find the relative velocity of rain with respect to the man, so that it feels like the man is stationary and it's just rain falling at him on in that direction. So it just becomes easier than analyzing in the moving in the ground frame where both the man and the uh, rain are moving. This is basically how we solve relative velocity questions also. So that was all about this video. Hope you like the video and other content that we're sharing on this channel. And please do like and share the video, subscribe to our channel, and if you find this video very helpful, then you can ask your friends and family or anyone who wants help with regard to such questions or anything related to NEET. Then ask them to subscribe to this channel, and we'll do our best to help you out. Thank you so much. Please do like and share the video and subscribe to our channel.